That's right, we're here at Vespa Motorsport in San Diego, California, also known as Scooter West. And that's right, we said California. Despite the fact we're in California, we're going to be talking about hopping up and doing a bunch of tuning work on a 50cc four-stroke today. So we've got a 2009 LX50 valve on the lift behind our camera there. And we're going to talk about a bunch of stuff, but first off, we're going to talk about this awesome Variator kit that is offered by Melosi. Nice thing with the Variator, it's a pretty simple, easy thing to install. You know, anybody at home with basic mechanics schools can probably play around with tuning the Variator to change the gearing of the front pulley to the rear pulley. So what do we got with this Melosi kit, Robot?
We got the Variator kit, and this Variator kit allows the motor to essentially have a higher top speed, kind of like an overdrive, or kind of like getting a 6-speed out of your automatic transmission, for to say. Also, the included weights are ideal for a stock, the original 2-valve. They're 6.1 grams. They allow the engine to rev a little higher, so it'll pull the hills much better, have better acceleration. And ideally, if you have a 4-valve motor, we would recommend the 5.5 grams. Melosi part number M669420.EO. And I would put those 5.5s in a 4-valve newer LX or S50 if you have a stock engine setup. It's a little different if you're doing modifications such as the 78cc top end, but we'll get to that later.
So again, we said the Melosi kit comes with 6.1 gram weights, and those are 19 by 15.5.
That's correct, yep. We offer those in 3 gram all the way to 13 gram. Typically with the 50cc 4-strokes, if you're going to play with the tuning, I would typically work with 4 grams up to 6.5 grams, somewhere in that range. I've never seen them go outside of that range.
What's this here?
That's the fixed plate. Has larger guides than the original stock one. A little more robust design.
Yeah, I must say those guides are the size of almost like a 150cc engine.
That's correct, yeah.
So it's nice, there's a little bit less friction as this plate, during operation, this plate is sliding in and out on these bosses. So those bushings are a high wear item on the automatic scooters. So it's nice with Melosi to put those oversized bushings.
That's correct, and they have the torque driver spring, kind of changes the characteristic of the whole overall transmission range. The weights that are with these is tuned to this spring, so it's very important you install this torque drive spring, and we'll show how to do that.
Yeah, so this spring actually, where that goes on the rear pulley, right?
That's correct,
back behind the clutch.
Behind the clutch there.
And I know that you were playing around with that LX50, and you started off by just doing a standalone Variator kit. What kind of performance gain did you get with just this simple bolt-on Variator kit? On a stock 2-valve motor.
On a stock 2-valve motor with just bolting this item on, you're going to get about 5 miles an hour higher top speed, and you're going to be able to pull the hills. We have a hill here in San Diego, Mission Hills. It's Torrance Street's over 26% grade. A stock LX50 with me, 160 pounds, will not get up that hill. You got to jump off the scooter and push it the rest of the way up. You just bolt on this Melosi Variator kit, it will power right up that hill, no problems.
So we're going to go through the step-by-step installation procedures. And one final thing about the performance of just the Variator, I remember when Robot first installed that, did his test ride, he came back, hopped off the scooter, and was like, damn, that makes a huge difference. You don't get that kind of results commonly with just the Variator kit, but this is one application with the 50cc 4-valve Vespa and Piaggio motors where it makes a huge difference.
Yeah, if you're just going to do one thing, bolt on the Variator kit. Very simple install. Then if you want to take it to the next level, we can go to the 78cc kit.
All right, so continuing on with performance and hot rodding our little LX50. First thing we're going to talk about, and this is the most bang for your buck probably, is the larger cylinder kit that's offered by Melosi. The part number on this is an M3113905. It's a nickel cell aluminum cylinder. Robot's got some of the specifications as far as displacement gain, bore, etc. So what do we got with this kit today, Robot?
This kit works with both the 4-valve and the 2-valve engine. You go up to 49mm bore, which is a little over 78 cc's, over 56% increase in displacement.
You know what they say about displacement?
No replacement for displacement. No other kit gives you that much of a gain, as a bolt-on item in displacement. Includes most all the parts needed to install the kit: gaskets, rings, special set of guides that are used on the 2-valve head.
So 2-valve only on these guides, 4-valve you don't use, you use the regular valves.
Pin, and we'll go over some of the other parts we recommend replacing in the install. And oftentimes, if you're going to do the kit, a good idea to go for the cam too. Longer duration and more lift, so added increase in performance.
It's very common that since you're going to be in there, you're tearing the cylinder head off to get to the cylinder. This is the opportune time to do this, and these two things are specifically engineered by Malossi to work hand in hand with each other. So this is the 2-valve camshaft, part number 5911988.
We got the 4-valve cam.
And when did they start making the 4-valve motor?
For America, it was 2010 on the S50. I think is when they put the 4-valve motor, but I think it's been in Europe since 2008.
So any 2011 or 2012 50cc Vespa Piaggio is going to have that 4-valve.
The 4-valve, yeah, they've discontinued 2-valve altogether.
And here's the 4-valve camshaft. Part number on this one is 5914211.
That cam must be used with the cylinder kit. The 2-valve camshaft can be used with a stock cylinder, but I've never heard of somebody just bolting the cam on.
And while Robot, sorry to cut you off, but while Robot mentions that, that's what the actual little notches and relief cuts are. That's for the valves, is the pistons traveling up and down. But essentially with this hot cam, if you don't do it with the cylinder kit, you're going to have major mechanical problems. That's disclosed all over the place with Malossi. But it'd be pretty silly to try and put a camshaft on a cylinder kit anyways. Okay, so we've got our 2008 or 9 or whatever this is, 2-valve LX50 up on the lift. We're going to be installing that cylinder kit, so we got to yank the motor. First thing you want to do is, let me backpedal a tiny little bit and say, we're going to really haul balls through the removal of the engine from the frame. We have an alternate video that documents the cylinder kit installation on 150cc Vespa. For the most part, it's the same chassis, extremely similar engine mount location and stuff like that. That's more detailed. If you go too fast for this one, check that video out. But the first thing you want to do is get the bike chalked up. We've got, our standard scissor jack underneath the floor pan. We've removed all the plastics, so the spark plug access door, the little floor underside cap, the side fairings, we've removed that on the other side as well. Robot's going to get into the, mechanical stuff that you're going to have to remove from this side of the bike.
All right, you want to get the muffler out of the way. 2 fasteners here. Keep track of the washers that go with those, and up underneath here, you remove the 2 fasteners that attach the header to the head. Want to drop the oil. 24mm fastener. Drain the oil. There's a connector back here. That's the connection to the actual stator. You can pull the boot away, and you want to pull this little tab and go ahead and pop the connection right off. A little bit tight, but you see the little tab pulls right off, and it separates the connector right from that motor. 17mm fastener. You'll need to hold the other side, but take that off, or just take the nut off at this point. We'll go on to the left side. You've got the rear brake. Loosen the lock nut with a 10mm wrench. Remove the nut at the end. Keep track that there's a little dowel thing that will fall out. Fastener here, remove this. Pull the cable out of this clip. Remove this fastener and reinstall, and separate the cable from the frame. Cut the zip tie, which I've already done. Pull the boot away. The air box, it's got 2 Phillips fasteners. I already have them out of the way. One here and one here. You need to do that if you're going to do the Variator kit. Separate the air box so you can pull the belt cover. And you could do that while the engine is in the frame if you wanted to just do the Variator kit. We'll go ahead and remove the battery. I already have the plastic cover off that has 5 fasteners that hold it on. You've got to pull the gas cap to get that out of the way. Perfect opportunity to put a rack on your scooter if you want to. Mounts to these fasteners. 2 screws for the battery, the vent hose, get the battery out of the way. This is the wire to your starter. It's got a zip tie right here that's reusable. You pull the little tab, go ahead and get that out of the way. This little clamp, pop that out. Separate the wiring. And once the battery's out of the way, you need to disconnect the large red wire that goes to this brown relay. And then with a 10mm wrench, disconnect this ground connection right at the frame right here. And you'll be able to separate the wiring from the frame. Much easier than disconnecting at the starter on the 50cc model. It's a little different on the 150 where you disconnect it at the frame. Again, if you've seen the 150 video, we actually remove the whole airbox and carburetor and leave it with the frame. no need to disconnect it. We're going to change a main jet in the carburetor, but you can actually do that while it's all in here. I mean, if this carburetor needs to be cleaned, you may want to take it further apart. 2 fasteners, remove the air box or the intake manifold, and you'll be able to put a wire and tie it somewhere to the scooter frame. Also attached to the air box is this vent hose that goes through the valve cover. You want to squeeze this little guy here, and you'll be able to pull that away from the valve cover. Spark plug cap, may need to get a needle nose. I also have the front access door open right here. You pull that straight out. That's separated. And now we're ready to pull the motor. Basically disconnect the shock, which is a 13 millimeter, 17 millimeter at the bottom shock mount, and then pull the pivot main axle bolt for the engine mount out. And we'll be able to lift the scooter frame and pull the motor out, and you'll see that in the next step.
All right, so we're going into the belt cover. Robots remove the final fastener on the bottom. 11 fasteners go around the perimeter. You got to remove the dipstick. Sometimes actually there's a little, there's a bearing that the clutch rides on, so a lot of times these covers can get on there pretty tight. We've got the fortune of a simple little slide hammer. Robot's going to show there's a couple tabs there,
tabs
there,
right
kind of anywhere.
Give it a little. They're now popped off. Sometimes it also hangs up on the dowels or the starter bend X as it is here.
Combination slide hammer, kind of jiggling the thing, never forcing it. So it gets the belt cover off, that exposes the front. This is where our Variator kit's going to go, is on the front pulley there. And that's the clutch, the rear pulley. The spring for the Variator is actually back behind, where it's behind there, right, Robot?
And we got the kickstart mechanism. Sometimes you want to make sure all that stuff's lubed up, and also check this bearing. Make sure it turns smoothly, and you can see this shaft actually engages into that little bearing there.
And that's the bearing that it kind of hangs up on upon disassembly, and the tricky part about reassembly. So that's it for the belt cover.
All right, we're going to remove the valve cover, the cylinder shrouds, 4 fasteners for the valve cover. There's rubber washers that you want to replace underneath here.
So you want to replace those every time, right?
That's correct, and also inspect the gasket that's behind here, replace if needed. And Steve's removing many of the fasteners that hold the shroud. You got 2 here. Keep in mind they're all different types of fasteners, so watch where they came off. Screw here, screw here. You're going to need to cut this one-time use hose clamp. Take a pair of dikes, and you'll be able to cut it diagonal. Get that out of the way. It's an air injection tube, and we'll pull up like that. On this side of the motor, you got a fastener here, one here, and this cover will come off, including this little one. This actually you can turn by hand. You don't even need a screwdriver for it. So we'll have all the cylinder shrouds off. Remove the upper cover right here. Sometimes it hangs up on the little tabs. Pop that off, and go ahead and remove the lower cover. Remove this gasket. If it has any cracking, replace it. Go ahead and set the engine to top dead center, and we'll go ahead and rotate the engine, and we'll get this little hash mark here, this pin, and this little dot all to line up, and that's top dead center. And you can go ahead and inspect the flywheel and also make a mark, such as how we did it in the 150 video, the key, the flywheel to where top dead center is. So for reassembly, it'd be much easier than finding the factory marks that are on the cylinder, or on the flywheel that is. We'll go ahead and loosen these 10 millimeter nuts in a crisscross fashion. This is the 2-valve motor. 4-valve looks pretty similar, other than there's two valves for intake, 2 valves for exhaust, and they adjust differently. The 2-valve engine uses a threaded adjuster that you can use simple tools to make a valve adjustment. The 4-valve engine uses shim pads, and we can show how to make that measurement upon reassembly. Loosen this fastener for the tensioner, and crack this one right here. And there's a factory tool that keys into this, but you can oftentimes hold the flywheel and loosen this, and loosen the 2 Allen fasteners from the side, and you'll be able to pull the head away, pop the cam gear off,
So again with the motor at top dead center, you want to actually basically draw a reference point on the case and carry that reference point over onto the actual flywheel. That'll be pretty critical for time to reassemble.
That's correct. Got your head bolts and the 2 cam tunnel bolts out. Have the center bolt of the tensioner out. We went ahead and cracked this. You need to hold the flywheel when you crack that. Go ahead and remove the tensioner.
Tensioner spring loaded, right? But you already took that.
Remove the spring before you take it out. And you can see that it's only used a little bit of its travel, so the cam chain's definitely in good shape. If it was out about that far, you definitely need to do a cam chain. Rarely see these cam chains ever wear out on these 50s. Remove the center nut.
Head bolt's totally, that's fully removed.
Keep in mind this washer, upon a reassembly, it's got a dome shape to it, so the kind of pyramid actually comes out towards the actual bolt. That's the outside. You do not want to install it that direction. So keep it with the nut. Go ahead.
It's also an opportune time to remove the spark plug so you can replace that.
That's correct, yep. Remove
it's
the spark
easiest
plug.
with the frame. It's easier with the engine on the workbench. I'm not going to do that, but obviously spark plug there. Robot went ahead and pulled the cam sprocket off.
Cam sprocket, a spacer.
Notice the sprocket's notched, so it can only go one way.
4-valve engine has a spacer, and cam sprocket's pretty similar to this. And now that we have this, it should separate. You can see this little plastic guide keys with that slot right there.
While Robot's tearing that apart, we'll take a quick note of the size of the new piston. You can actually check it with a tape measure. That says something. Normally you use a caliper for something like this, but the new bore is almost a 2-inch in diameter. I'm going to rotate this a little bit. That's okay, right, Robot? Mm-hmm. You can kind of see the huge size difference. I mean, the standard bore, what is that? I know we're using a tape measure, not really what you normally use, but what, 1.5 inches, almost like that. Well, that's a pretty huge difference in piston size. So.
And these dowels are not reused. These are the 2-valve dowels. The dowels that are included with the cylinder kit are going to be used. They are a little bit different in style.
A lot of times they'll stick a little bit on the base gas. I think Robot's going to run over and get like a bit of a brass hammer, dead blow hammer. Just got to tap the cylinder off a little bit. All we're fighting right now is basically the base gasket is keeping the cylinder stuck to the actual crankcase. Hey, here's Robot. There you go, just saw him tap it loose.
Basically broke the gasket free. Go ahead and pull the whole kit right off. If you want to leave the piston with the cylinder, you could actually pull the clip out. But we'll just go ahead and pull the
cylinder all the way off.
And you can see a dowel here, dowel here. Be a good idea to put a rag in the actual spigot hole.
Now Robot's actually going to remove the wrist pin clips. That's kind of tricky. You're going to use a very sharp pair of needle nose pliers. But we stuff the rag in there because as these clips come off, sometimes they can be known to kind of pop in any particular direction. You don't want them popping down. And we're not going to disassemble much further than this for what we got to do today. Another thing on that cam chain too, Robot, is it pretty critical to make sure this doesn't fall down in the crankcase?
No, you can retrieve
less critical on
these
motors? Okay.
Pretty easily, so be care not to stab your hand, but just pry away. You see the clip went away, but I have the rags in here. And you'll be able to push the pin through. If the pin does not push through, you can heat up the piston with a heat gun, get the piston to expand a little bit, and the pin will pop right out.
All right, so we basically got side-by-side comparisons of a 4-valve head. Again, the 4 valves on a 2011 and newer, and the 2-valve head. The 2-valve head is the one that came off this particular engine. So 2 valves are 2010 and older. In theory, you could actually swap the head over onto the 2-valve motor, but you'd have to change all the shrouds. So, you know, may or may not be very cost-effective in order to do that. But you kind of look at, obviously, the 4 valves versus the 2 larger valves. Completely different profile of like the little combustion pocket. It's kind of interesting to look at that difference. The exhaust port, you know, larger on the 4-valve than on the 2-valve. Rotating this way. They use 2 different spark plugs. Robot, what can you tell us about the spark plugs? Oh, and look at actually the size of the fins on the 4-valve motor too, huh?
Yeah, the shrouds look completely different. The valve cover's different on it. This is the air injection tube. We sell a block-off plate. The same block-off plate that's for the LX150 will work for this if you want to eliminate this air injection system. Obviously want to replace a gasket if you do mess with that. The 2-valve head uses a more standard spark plug, a CR8EB is the original plug that came out of there, and we have an iridium replacement for that. And the 4-valve uses a very unique smaller plug. It's the ER9EH-6N. It's a real small spark plug. You need a 13mm deep socket to remove it versus the more standard 5/8 spark plug socket to remove the 2-valve head spark plug.
Rotating this way to look at the two different inlet ports. I mean, huge difference. Again, look at the size and the, actually put something in the robot to give a frame of reference. We look at the size difference. Inlet port 4-valve again in my left hand and the 2-valve in my right hand. What's that little sensor up there on the 4-valve?
We got a temperature sensor on the 4-valve engine that controls the ignition timing at different temperatures. Probably pulls the ignition timing if the engine gets hot, adds more timing when it's cold. The cams remove pretty similar. This retains the 2 pins for the rockers. This screw is pretty difficult to get out sometimes. You may need to get a vice grip on the screw to crack it free. For the 2-valve, there's only a single pivot pin. The rockers are actually identical. You want to mark them in intake and exhaust when you take them off.
This robot's already written in IN and EX.
Yeah, on the 4-valve one, they're unique to the intake and exhaust, so you cannot, they need to go into respective spots, but it's a good idea to mark them so you don't lose track. Remove this single fastener, and it allows you to pull the pin out, and it allows you to extract the cam. With this one, pull the screw out, pull the 2 pins, you'll be able to remove the rockers. Pull the C-clip out, and you'll be able to slide hammer the cam out. Sometimes the cams will pull right out. There's a Piaggio factory tool for pulling out, but I found you never need it. The slide hammer will do the trick just as well.
This is not left-hand thread or anything?
Nope. You can see Steve's having some difficulty removing that because it's got some Loctite on the threads. And same with this washer. Sometimes this washer won't come out. You may need to pry it out. You can see some of the residue of the Loctite. It's also got a dome to it. So the kind of pyramid shape goes on the outside. You want to clean that Loctite residue out of there. We'll go ahead and pop the pin out. This usually pops right out pretty easy. And I'm doing this again on the 2-valve. So we pop that out. Pull the pin out. Separate the exhaust. And there's your intake, and I usually slide them back on the shaft, inspect the lobes or the hardened surfaces. The hardened surfaces look perfect. Same with the cam, we're replacing this cam.
Again, we're going for the Melosi Performance camshaft to go with the cylinder kit.
Didn't need to use a slide hammer, but sometimes you may need to thread a screw in here and slide hammer the cam out, or heat up the head ever so slightly to remove it. This bearing, you can either opt to replace it. We have these bearings available. Or if you like, we could press a new bearing onto your camshaft before we mail it out to you. But this bearing, if you want to extract this, you could put this in a vise, support the bearing, and carefully tap the shaft through. And as long as you don't damage this bearing, you
How tight a fit is that? I mean, do you need a hydraulic press, or can you kind of do it?
Don't need a hydraulic press, but you'll need to tap it with like a brass hammer or something to slowly drive that out. And we'll go over to 4-valve head. All right. We're going to go ahead and disassemble, tear down the 4-valve head. Take the screw. Again, sometimes it's very difficult. I already cracked it free. If you damage the screw, you can see I kind of put some marks on it from grabbing it with a vice grip. You may want to replace that screw. Again, I have the valve smart. So there's our exhaust. Again, keep the pivot pin with it. Intake. Pull that out, keep the pin with it, inspect the surface, all looks pretty good. As you can see, there's these little pads that are marked with numbers. These are actually calibrated precision ground little pads, and they actually do remove. You might want to use a little magnet. And you want to take a cardboard and draw an illustration of the head, and when you remove them, looks like these 2 intakes are both 270s, and we got a 260 or 280 and a 280 right there. They need to go back in the same spot, and when we reassemble the head with the new cam, we need to recheck the clearances, and you may need to change out those shims. There's a lot of other videos on doing valve adjustments on dirt bike engines that have a similar setup. You can go through the Piaggio service manual. It'll give you an outline on how to calculate the correct shim sizes that are needed to get the valve clearance within the correct specification.
Real quick, Robot, let's backpedal a little and show the rockers for the 2-valve ones, because they're completely different as far as the adjustment. Robot talked about the different size shims on these, but those are more a conventional one like most people are probably used to seeing, where you crack the lock nut and adjust the tappet, correct?
Yep, crack the 8mm lock nut when the cam's in top dead center. You can loosen or tighten the screw. You could put the feeler gauge underneath this pad between the top of the valve. And both for the 4-valve and 2-valve engine, it's 0.10 of a millimeter for the intake and 0.15 of a millimeter for the exhaust. And so about 4,000ths or 6,000ths if you're dealing with inches.
And in order to change these shims, you have to actually pull the camshafts out each time and everything?
Don't need to pull the camshaft out, but you need to remove this screw and remove whatever rocker needs
so you
to
have to move the rockers. I meant to say rockers.
And again, you know, you can use a magnet or something, actually pull that one out. And we stock all the sizes of these replacement shims.
So that's the shim, that little tiny puck thing that's the size of the head of an eraser, basically.
That's correct, yep.
So he's pulling the circlip out. That's all that's basically holding the camshaft in. Again, we'll see how lucky we get as far as how difficult it is to pull the camshaft out on this one.
That one's coming right out. Pretty much identical to the 2-valve cam for the bearing. You know, the bearing, you could reuse it if you want or replace it with a new bearing. But you can see it's driven all the way to the shoulder of this cam here.
And I mean, I'm much more novice than Robot, but go ahead and pull that cam out, Robot. And the first thing I thought when you think 4-valve is you expect there to be 4 separate lobes. You know, each one of those lobes essentially operates the rocker, which opens and closes the valves. But can you explain, Robot, why it's a 4-valve yet there's only 2 lobes on those camshafts?
Well, this style system still uses a rocker, so you got one lobe that actuates the 2 valves, so it's a Y-shaped rocker. Some motors that have double-ordered camshaft, they actually have the lobes that actually act on the valves. You know, there's many different setups for valve trains on motorcycles, scooters. Piaggio tends to use single-ordered cam on almost all their models, is what I've noticed. So.
All right, so we've got side-by-side comparisons of the multiple camshafts. The Malossi ones are labeled Malossi, and also the Malossi ones are the ones without the bearings. But Robot can kind of point out the lift. There's one measurement you always hear about on camshafts. You hear lift and duration. Those are the two, forms, how they kind of calibrate and determine like the performance aspects to a certain camshafts. The lift is pretty easy to measure. Robot will show how you measure the lift. You can do that with a simple caliper. Yep. The duration is a little more complicated, but the duration you'll be able to tell just by the difference in the lips.
You can actually physically see that the lobe is actually a fatter lobe on the Malossi camshaft versus a stock. So it basically holds the intake and exhaust valve open longer, so you get more of a charge on the intake and a better exhaust charge, or exhaust, on the exhaust stroke. So it's basically just holding the valves over longer, slightly more lift, and they also have a little bit more overlap.
Robot mentioned the lift. We're actually able to measure that, so lift is basically that overall dimension there. On the stock one for the 4-valve motor, you're looking at 24.1 millimeters, and on the 4-valve Malossi one, you're looking at 24.5. So that's an increase in lift in 0.4 millimeters.
Yeah, about 4, but it's a little bit different because of the ratio of the rockers there. So, but it does have a little bit more lift than the stock one. And
moving right along, Robot will kind of hold the 2-valve ones up, and you can get the same thing. You can see the visual difference in just the overall size of the lobes. Again, the Malossi one here that I'm touching, and then the stock one there, you can see the size difference in the lobes. Just a little bit less increase in lift on these ones. The stock one measures at 25.7, where the Malossi one measures at 25.9.
All right, next we're going to go ahead and swap the bearing over. Like I said, you could support this in a vise and carefully tap this out, or you can optionally just replace this bearing and set this on a socket or in a vise and carefully tap this down. One thing to keep in mind, these new Malossi cams, they have like a cosmoline coating on them. You want to clean it off with a carburetor spray, and then we'll thoroughly lubricate this cam before we install it with assembly lube.
That's my job. I'm low tech. I'll get on the cleaning. All right, so we're going to go ahead and take the bearing off the original camshaft. Notice we've got the bearing basically supported in a vise here. We've got a red shop rack protecting it. Simple little rubber face mallet. It's actually not that tight a fit. kind of get it started like that. And then carefully, with a punch, you can kind of finish it off. So that's the camshaft. That's the low-tech stock one, straight in the trash. And then reassembling the new one. Make sure everything's clean. We've cleaned the camshaft. Whoops. Start that again. You can kind of carefully support this in the vise. We've got a 12mm socket, so we can push down on the inner race on the new bearing. We're just going to tap this on very gently. Certain amount of feel. You can always feel when you're drifting like a bearing or something on a shaft. You can always feel when it bottoms out. That's pretty much it. You can do a little visual check down there. But that's it. So the new bearing's been swapped over. We're ready to install this camshaft.
All right, we've with this 2-valve head, we've cleaned it. We've already leak tested, basically filled the ports with gasoline, checked to see if there's any leaks. No leaks on it. Check the surface is perfect. You can see in our 150 video on how to check all those. We got the cam all assembled, thanks to Steve. Need to put some assembly lube on a couple of the surfaces on it. Basically just put it on there pretty liberally, and same with the bearing, put a little bit in there. And with the lobes facing down, the 2 lobes, you could actually go ahead and slide that right back into the and you can see it went right in pretty easily. You may need to tap it with a large socket if you have any difficulty. Turns freely, that's good.
So again, we've got the lobes facing downward. Right, Robot?
That's correct.
Okay.
Intake and exhaust valve. This is our intake right here. Exhaust out that way. So there's your exhaust valve that this is going to act on. Go ahead and pop the pin out. Again, you can put a small amount of lube on it if you want.
An assembly lube, for everybody that doesn't know, that basically just lubricates, a freshly built motor, those components, until it has a chance to get lubed up with the oil that's splashing around and pressurizing the motor.
That's correct. And go ahead and slide that in. If you have any difficulty sliding it in, you're going to need to loosen up these valves, and you're going to need to check the adjustment. Once again, same with the 4-valve engine. If it's too tight, you're going to need to put a thinner shim in there and figure out exactly what shim to get your 4,000ths and 6,000ths clearances for the exhaust valve. We'll go ahead and check this. You put the sprocket on here. Keep in mind the spacer goes back on, but we're not going to deal with that. We're not going to, we just want to get it set at the top dead center. It should be pretty close because the lobes are facing down. And while the cylinder is sitting on the table, you can check it. There's our 6,000ths, 1/1500ths of a millimeter. And that feels pretty good. It's a little on the loose side. Let's go ahead and make an adjustment. I got the fancy little tool.
This tool is cool. It's actually got a socket so it cracks the lock nut loose, and then you can actually, with the thumb drive up on the top, you can actually tighten it down and set the valve clearance, and then tighten the nut back down, so it eliminates all guesswork.
Now that feels good. And the 8,000ths won't fit in there now, so that's good. Just check the intake, 4,000ths. It's a little tight in there. Yeah, I got it under there, but it definitely drags really tight, so I need to loosen it out a little bit. And key that with the flat slot. And one thing to keep in mind with these 50cc motors, the first service you're supposed to check the valves. And a lot of people neglect to do that on these motors. Alright, now that's set. The valves are set on the 2-valve head. Again, the 4 valves are a little more complicated. They're actually less likely to need adjustment with the shims in there. And we need to put the screw back in, clean out the Loctite. You want to put a small amount of blue Loctite on the threads and tighten that screw, maybe 4 foot-pounds at the very most. The 5mm screw, pretty small. Alright, got a little bit of blue Loctite, got the beveled washer so the pyramid kind of faces out. And we'll go ahead and thread this in here. You don't really need a torque wrench. Be a real small inch-pound torque wrench if you did want to torque this to the. We'll go ahead and you can see it's driving the pin the rest of the way in, and right when it snugs, just give it a little snugging. That's all it needs. Again, I put the blue Loctite on there.
Oh yeah, Loctite. Tasty. I'm gonna pump this cylinder full of purple spray, a little degreaser. You gotta prep the cylinder walls. Simple way to do this is to start with a few clean white paper towels. You wanna give it a good little spritzing. Spritzing. That's for our friends in Germany, that's what they would say. So just liberally apply it to the cylinder walls, wipe it out. And all you wanna do is you basically wanna do a couple wipes with the first paper towel and then pass them through until they're basically clean. So you wanna do like the white paper towel double check. So it's still a little dirty. Basically want to keep spritzing it down until you wipe it and it basically comes out just the color of the purple power. You can use simple green, anything like that. Our shop we use the purple power, so you basically want to do that until it comes out clean and all you almost see is the purple spray. Surprisingly, this cylinder is actually a little bit dirtier than normal, but this is a pretty important step getting ready to prep the cylinder for installation. Oh yeah, we're clean now. Let's install this bad boy.
All right, I'm gonna prepare the piston before installing it. A couple things, the note, this little arrow always points down towards exhaust on these engines. We're gonna put the one of the clips in, the one that's closest to the cam train tunnel. You can see the little knockout right there. You grab the clip with the needle nose, good pair of needle nose, grasp it pretty tight and just kind of roll it right into the groove. See how I rolled it right in there? Kind of got my finger in there, keep it from popping out. And next you want to just definitely pop it into the groove, make sure it pops into the groove. You know, double check it all the way around. You can see it's not all the way in there. Definitely want to check it and make sure it's in the groove. So we got the one clip in, the only one installed the one clip. Next we've got basically 4 different types of rings. Or you got the kind of chrome plated edge with a gold or kind of a copper finish, that's your top compression ring. The kind of cast iron dark graphite color rings are the center ring. You got the 2 scraper rings that are identical, there's no direction to these. And then you got the tensioner spring for the scraper rings. There's an order on how these go, and there's also positions where you want the gaps. Again, the arrow points down. We'll put the first one, which is the actual little spring thing. The gap's going to go up at the top. This goes on the larger groove at the very back of the piston. Next, you take one of these scraper rings. Again, it doesn't matter. There's no orientation to it. You got the gap here for the spring. We're going to put this gap kind of parallel with the skirt here, and then we'll put the other gap parallel with here. So we'll put this one on the bottom here. Carefully just expand it, drop it around the piston, and voila, let's pop in, there's your gap.
And again, those rings, there's no top or bottom to those, right, Robot? Those
That's correct,
go
yeah,
either
they
direction.
can go either direction. And again, make sure they don't go into the other ring grooves. And just carefully lift them. Yep, there you go, I popped that one into the center groove, but now it's all in there. You could squeeze them, sitting kind of on top of the spring there. Next ring we're going to put on is the cast iron ring. These have a direction, they have an in on the top. So the top being, it faces towards the crown of the piston. We're going to put this one down here. What is that, like?
To kind of line that up with the bottom edge of the skirt of the piston?
Yeah, something like, yeah, right about right there. So not, I don't know, what is that, 4 o'clock, something like that.
So on the topmost ring has also got a little marking on
right
it.
there. Again, put the great gap right there, pop it on carefully.
So yeah, if you look at the piston like it's for a clock, you always want to stagger the ring end gaps. So one at 4, one at about 8, and another one at 10 and 2 or thereabouts.
Mm-hmm. So that's all prepared to put on. Put a small amount of oil on the pin. Oil up the pin, make sure it slides in there pretty easily. Just leave it right there. Go ahead and grab the cylinder. There's your cam chain adjuster that goes up. And you can go ahead and install the piston. Put a very small amount of oil on the piston. Just a little bit on my finger, that's all I need, that's more than enough. Basically you want to oil the cylinder, you want to take a rag and wipe it back out. Some people tend to want to over lubricate these. All you need is enough oil that's actually in the cross hatching pattern, you know, kind of a microscopic film of oil, and that's all you need. So again, piston faces down. There's actually specific tools for compressing the rings, but I've found you don't really need them. Kind of look at the ringing gap, kind of use your nails or a small screwdriver, pop it in. Obviously a lot easier if you don't have gloves on, kind of a feel for it. So I got the first ring in, now second ring. I carefully drop that down. You know, some people install the piston on the connecting rod. It's a lot easier to get the rings all seated before you do that. So there we go, all of them in. The last ring's going pretty simple. Definitely want to make sure the rings drop down, don't start to fold up. Sometimes people damage the oil control rings. So this is ready to assemble. Goes like that. Put the pin, line that up, and basically pop that in. And put the last clip in. Obviously you want to put the rags back in place. Don't want to lose your clip into the bottom of the engine there. Here, this is, cylinder deck is all clean.
But it's cool, so you can kind of see the thing, the way it goes back on. And it's nice robots like we did early on. It's got that clip already seated. It's difficult to get to that clip with the valve train stuff in the way. And this is the way that the pros really kind of get a cylinder ready to reassemble. So like you said, you're not fighting the rings, fighting the cylinder studs. This is the way to actually do it.
Extra hole goes on the bottom. The dowels are already in place.
No silicone or anything on that gasket?
Nope, it's a treated gasket, doesn't need anything, so.
How can you tell it's treated? Is that green color?
Yeah,
in general?
most of the time they're green, kind of have a waxy film to them. They don't need anything applied to them. Then Steve's helping me out here. Kind of aim for the piston pin. Of course, there's a little bit of lubricant on there, the oil. Pop the rag back in.
We'll rotate the engine a little bit so we can see. But yeah, all I did was kind of center the rod. Robot looked down from the other side, and then he just pushed the wrist pin in. You know, notice there's virtually no interference fit, so he was able to literally push that in with his pinky. He's got the rag stuff back in there. Again, these clips are the most technical and tricky thing.
Yeah,
that rag
roll it
keeps
in there.
the case, which obvious reasons would cause a problem.
And there you go, pop it in. You may want to use a flashlight and double check, make sure that ring is in the groove, because if it pops out in the cylinder, it will damage the cylinder. Go ahead and pull that out, and I already know my other one. Last little bit of lubricant, put a drop on the skirts here.
Just the drop.
Just a drop is all you need. And get the cam chain back up in here. Use a magnet or whatever. A lot of times I like using a needle nose to kind of put some weight on it, keep it. And we'll go ahead and.
That is just kind of jiggling the cylinder down, not forcing anything at any point in time. He's watching the general look around and make sure everything kind of seats correctly. You got to blow it pretty majorly to, like, you know, not get that thing seated correctly.
And you could, if you want to turn it over once, just to check it. You know, back to top of the center, we have that mark there. You can see the pistons nearly at the crown. With the stock cylinder, they have two different base gasket sizes. With the Veloci kit, you just use the included gasket. You could do measurements to figure out the squish on these. No need to do it with the Veloci kit. They're machined a lot better than the original. All right, we're going to go ahead and reinstall the head. With the 2-valve head, you need to use the included dowels that are with the Veloci cylinder kit. If you're installing the 4-valve head, or just reuse the dowels that are included.
Where do the dowels go? Which 2 cylinders?
Basically, the dowels go.
Oh, you can see on the head.
Yeah, you can see they go in these 2 spots here.
The larger bore.
So up here and down here. With the gasket drops off, make sure this is perfectly clean. And we'll pop the cam chain through.
Again, no sealant on the head gasket, never ever. This gasket's included with the Melosi stuff. The spacers, the stepped ones, again included with the Melosi gasket or with the Melosi cylinder kit.
So dowels are on there. Head's ready to drop on. I've cleaned this perfectly and checked to make sure it's perfectly flat. You got the lower cam chain guide. It's got that little tooth that just drops on that little groove right there.
I'm gonna try not get in the way. That's my objective right now. Oh yeah.
Again, piston still top dead center, indicated by our mark that we made when we were tearing down the motor. And this bottom part kind of drops in a groove. You want to make sure it's on that little step right there. You could actually pull it out right from up here. And it sits there right on that step. It won't move back and forth. We'll go ahead and just spin.
Flange nuts back on.
It was the original cylinder. Piaggio's torque specification is torque these to around 4 foot-pounds. Wow. It's a real small measurement. And then you torque them 90 degrees. And some of the higher end torque wrenches will count 90 degrees and you do it 2 times. So 4 foot-pounds, 4 foot-pounds, 90 degrees, 90 degrees. And then you go around one more time and give them all 90-degree turns. And that's the torque they need to be torqued to. In the Melosi literature, they specify 9.6 foot-pounds, and much easier if you have just a regular torque wrench. And ideally, you'd torque them 4 foot-pounds, 6 foot-pounds, and then the final third torque would be 9.6 foot-pounds in a crisscross diagonal pattern. So I already have my torque wrench already set, 9.6 foot-pounds, and I'll kind of just watch the meter on this. Right now, they're just kind of snugging. I'm up to about 3 foot-pounds right there. 3 foot-pounds on that one. Again, it's critical to have a good quality torque wrench to do this. Go 6 foot-pounds. Right there, 6 foot-pounds. 6 foot-pounds. 6. 6, and the last one will be their 9.6. Been a little looser. There we go. So they've all been torqued to 9.6 foot-pounds. Drop the 2 Allen fasteners. They're around 7.5 foot-pounds. And Steve will go ahead and torque those. We have a Allen fastener.
Again, 9.6 on these, right, Robot?
No, these are around 7.5 foot-pounds is what you want these set to. And I'll just get them there. They just need a little bit more to probably get to 9 or 7.5 foot-pounds there.
I'll kind of hop back and forth a little bit, probably not totally necessary, but good habit to get into, always kind of step torque and stuff. So went to about 5.5. Digital display on the torque wrench. Starts buzzing right when you hit it. Voila, I think Robot's gonna, what's up next? Cam sprocket.
We'll get the cam sprocket on. Very important to replace the spacer. That little spacer goes on the shoulder right there.
Not to replace it, just make sure you put it back.
Make sure you put it back, correct, yeah. The sprocket, again, you got the mark that lines up with this dot. Or on the 4-valve engine, there's actually the center of the screw head that's right there. So we'll go ahead and get that in there. Make sure your mark is on the flywheel, and you can put your finger in there, kind of make sure you're all lined up right.
We're gonna Loctite this on, or?
Generally, I put a little Loctite. Originally, they never had Loctite on those, but not a bad idea.
I don't even know how this thing works. How does that work?
Pull it out.
Pull it out. Got it.
Real small amount. Don't need much. This washer has got a kind of that bell shape to it, pyramid or whatever you want to call it. So it's tallest right in the center where I actually never removed the washer since taking it off. And we'll go ahead and torque that to the same 7.5 foot-pounds.
Is that 10?
Again, there's a Piaggio tool, that pin tool that holds those, but you could just hold the flywheel.
7.6 you said?
Yeah, and I've found that it, never really, there you go.
That was it.
That's all it takes, and even without the tensioner, it doesn't seem to ever jump the cam timing or anything. You might double check it again.
Double check what? So we want to make sure that
The dot's there. We'll put the tensioner and double check it
Got
after
it.
we do that. Gasket that's included with the Mosi kit. And I reset this tensioner by basically, it's out wherever. You push that little tab right there and you pop it back in.
and you'll readjust that once it's installed, or is it
No, it's
self-adjust?
self tensioning here, so go ahead and pop that in. 2 fasteners. And if you wanted to torque it, not a critical fastener, so just snug them both. If you want to torque them, 7 foot-pounds would be ideal for those 2 fasteners. O-rings in place. The small spring, pop that in. Pop this in and go ahead and tighten this down. This is actually a fairly fragile bolt because it's hollow, so if you're going to torque with a torque wrench, something like 4 foot-pounds, just a little bit, and now it's tight. You can go ahead and turn the motor over. Let's make sure it works. And set that dot and make sure your mark's lined up right there, and everything's lined up. I can see.
Double check everything looks good here.
Yeah, if you want to double check the valve measurement, we went ahead and checked it while the head was off.
See that, Boo? There's our original mark we made. So that's our double check mark too, huh? To make sure everything's good here.
Spark plug is already installed on this.
That's right.
It's a good opportunity to put the iridium plug if you have the 2 valve head. With the 4 valve head, you're kind of limited to the stock NGK plug. Put this gasket back on. If there's any cracking on it, you may want to replace it. We'll put all the shrouds back on. It'd be a good idea to wad up a small towel or a bag and put it in your intake. As you bolt together, make sure you don't drop any screws or anything down there. So.
Valve cover and then shrouds?
Yeah, and ideally with the valve cover, if you're up there in the miles, a good idea to replace this gasket, but every time you separate this valve cover, you want to replace these gaskets. 4 of them, and they're part number 249039, and you go ahead and replace those. You can see that they've been compressed, and they just pop right off the old ones. And another thing is put a little oil in the pockets. There's these little holes, the oiling holes. I got assembly lube, so it's kind of a little bit redundant putting oil in there, but can't hurt.
All right, so here we are. We've actually got our shrouds all reinstalled. The bottom cylinder shroud and the upper cylinder shroud kind of clipped together. Again, paying attention, there's a couple key fasteners. Those self-tap, like the machine screws, those are the ones that screw into the aluminum. The self-tap, being more coarse ones, are the ones that screw into the plastic. Make sure you put that little vent tube clamp on that one. So these 2 go together. Then we go ahead and put the flywheel cover back on. Pay attention, that little special thumb screw goes there. We've replaced that like cut-off style one-time use hose clamp with the conventional worm drive one. Ready to actually install our brake-in oil. Generally, just like with all the, not all, but pretty much all the Piaggio motors, you're supposed to use a 540 fully synthetic. We're doing a brand new cylinder kit, so you always want to use a good quality conventional brake-in oil. Using a Motul 1040, or using 850 milliliters. We've got a nice graduated cylinder and a funnel, so we can kind of pour this in. Know that the oil's going to be at the right level. And then we're moving on to the next thing after this.
We're going to go ahead and install the Mosi Variator kit. First, we need to remove the old pulleys. You can wedge like a number 3, number 4 Phillips screwdriver in here. Gotta do this extra carefully. This is not really the factory prescribed method of doing it, but it works perfectly well. I've never broken a case. Another option, just use an air impact to zip that off. So get that in there, see some kind of hole in the engine. It's obviously a little easier if the engine's in there, so crack that one free. Piaggio recommends that you replace this nut every time. The actual driven pulley, the part number. For holding this clutch, there's two methods you can use. You can use the universal holding tool. Basically, this goes around the clutch, and you can crank this, and the span will tighten up there, and will hold the clutch. Another thing is another tool, like the factory tool for doing this, has 2 pins on there. Basically, you get it into the clutch, and basically lock that up, and then be able to spin the nut free.
Part number on the nut that holds the variator on is 289519, so that's the front nut, 289519.
And Piaggio recommends replacing every time. For some reason, they don't say replace this one, but they're actually identical between the front and the rear, which is all the other models, they actually use a different nut, or many of the other models. Clutch belt comes off, you might want to clean that, scuff it up with sandpaper.
And what exactly are you scuffing there? Your case is scuffing the friction lining.
Yeah, the
right?
friction lining, if you wanted to scuff that surface. Make sure there's no oil or grease contamination. If there's oil or grease contamination, you really need to rebuild this whole driven pulley assembly. You could see one of our other videos for details on how to do that.
So you can see here, these are the friction clutch shoes. So those basically contact the drum. So what he's saying is inspect these and make sure there's no grease oil contamination. And there's actually grease packed in these 2 seals, right? So
That's correct, yep.
if there were oil or grease on one of these, it's likely one of the inboard or outboard seal failing on the clutch. Hence the rebuild to the clutch over.
Sometimes when the clutch gets grease on it, it's actually kind of grabby.
So it doesn't slip on you.
Yeah, it doesn't engage and
Does all sorts of weird stuff.
This side comes off. There's the kickstart engagement gear, the plastic fan. If you've broken a belt or something, or overheated the engine, I've seen these melted before. This steel pulley right here, it's still in pretty good condition.
Go ahead and talk about the splines, right, on the inner shaft.
Inner shaft's got splines on there. Make sure those splines are tight. If the Variator center nut comes loose, oftentimes it will take the splines out on this pulley and sometimes damage the crankshaft.
I will say from the spare parts perspective, it's like we go through a lot of those outermost pulleys, the spline ones, and then these plastic fans. There's serious casualties of war on a lot of the 50cc engines. The ET2, I think, uses the same plate and the same fan. They look extremely similar.
ET2 is a very similar layout to the 4-stroke. Starter Bendix gear, if you want to remove it, inspect it. Go ahead and pull the clutch off and take the belt off. You can see the belt's got a direction to it. I think the service limit on these is 17.5 millimeters, so you measure the width in a couple spots. If it's under 17.5, it'd be definitely a good idea to replace this. If you're doing a performance build, if you have more than 2,000 miles on a belt, it'd be a good idea to replace this.
So 17.5 is the service limit. I mean, if that thing were 17.7, I mean, what does it start off at? Do you have any idea?
I don't know. Generally, it would be about, they say 1 millimeter larger. So I haven't really measured a new ET2 or LX belt, but I think they start out 18.5. So new belt's 18.5, the limit's 17.5. So if you're at 18, you're half-life with the belt.
Okay.
For the most part. This little boss comes out. For the Melosi Variator kit, you don't reuse that, includes that part. Get your finger back here, kind of, because oftentimes these barriers will fall apart as you kind of slide them off the spline shaft. Kind of doing it from the side, I have a little difficulty here. And have that. You can see the shoes. The Melosi one are much larger. These little plastic shoes that commonly wear out and you want to replace them. Stock roller weights in these, I think they're 6.5s for the 2-valve, and they're I think 5.5, or no, they're 5 grams for the 4-valve. Obviously a 4-valve engine revs a little higher, hence why it has the lighter weights. Same roller weight size as the Melosi. We have both. If you're going to replace the stock Variator, you can put the Melosi roller weights in there and play with it.
And again, the size on the stock ones and the Melosi ones are 19 by 15.5 as far as the dimensions of the roller. A lot of people kind of ask about the rollers. There's the physical weight to the rollers, which is one thing, and there's the actual dimensions, so the diameter of the roller and then the length of it. So there's kind of a lot of different roller sizes for different applications. So a lot of times on the parts side, when people kind of call, we ask if you know the size by any chance. That's what we're asking for. So the diameter, the length, and then finally is the actual weight.
In here, this is actually a timing cover. It removes if you ever need to change out the seal or get access to the timing system under there. Make sure there's no oil puddling in there. Oftentimes if you have your engine oil severely overfilled for too long, it will blow that seal out. And this cover actually removes to change out that seal. For the rear shaft, there's also an oil seal here. Make sure that's clean. We're going to go ahead and tear this apart. There's a factory tool that actually compresses this whole deal, but these little 50 clutches are under such little tension, you can actually just hold the clutch. And you're going to need a 34 millimeter socket. You can find a 34 millimeter socket at your local auto parts store. Typically a size for like a front wheel drive axle or of some sort. So 34 millimeter is a pretty large size socket. It's not really included in a regular half-inch socket set. You might need to get that separate.
So here our belt measures 17.9 millimeters, service limit 17.5. I think this bike only has 1,000 miles on it, so we said earlier that potentially this thing might have started at 18.5. We'd have to double check like a brand new one, but it's probably actually a little bit less than that. It's not very likely that a belt on a stock 50 would have worn that much in such a short period of time. But at 18, we're just going to go and wind up reusing this belt. It's still good.
All right, ideally, you put something like this on the ground, hold it with your feet. Don't really want to try this with the larger clutches because they are under a lot of tension. You know, stand back, and there you go. Now you just let the clutch assembly. This is actually the whole clutch assembly. Clutch springs, if you want to play with those, change the engagement point of the clutch, you could actually get a Melosi set of clutch springs and play with those. This plastic spacer comes off. Check the operation. Again, the seals, make sure there's no grease leaking. This should kind of turn in a real smooth, shouldn't have any free play in it. You can kind of inspect in there, make sure there's grease. It looks pretty dry. You can dab a little grease if you need to rebuild this. In another video, we cover how to rebuild this thing. You know, this actually all comes apart, but we're not going to deal with that right now. So it's in good shape. Here's the Melosi spring. Drop that on.
Let's do a quick little side-by-side comparison of the stock one versus the Melosi.
Pretty much exactly the same, just a little bit higher spring rate. That's the only difference.
A little bit higher spring rate, so there's more active springs you can kind of see. And actually the diameter of actually the spring actually looks a little bit fatter on the wagon.
Yeah, hence why it's got a little bit stronger rate. And it's been designed to work with the Melosi Variator kit, so that's why it's recommended you change that out. We'll go ahead and pop the clutch back on. Again, it doesn't take much. Have a partner. If somebody get this on the D-shaped shaft here, go ahead and start the nut, Steve.
There's a top and bottom to the nut. The pen mark is on the facing up. It's also kind of a little flatter. Basically get it started, and now a robot can kind of take his hands off of it. It's going to safely stay compressed.
And the recommended torque for this, I mean, you could carefully clamp this with a rag and a vise and take a larger torque wrench. I think you torque it to
42 foot-pounds. Is that right?
Yep, right around 42 foot-pounds. You can see there was actually a mark. You know, if I hit it with the air impact and had that mark, it'd probably be pretty close. If you want to, you can put a little Loctite on there, small amount. Don't want to put too much. But we'll go ahead and torque that to 42 foot-pounds again and clamp this in a vise with a rag around it and go ahead and torque that. There is a Piaggio tool that holds this whole thing together, but we're not going to cover that since you're doing this at home. Don't really need that tool. All right, ideally, we've got the Variator all set up. They include 6.1 gram roller weights in there. If you have the 2-valve engine, you could probably go, ideally it would be somewhere between 6 or 5.5 gram would be ideal. If you're working with the 4-valve engine, you want to go a little lighter. Those engines tend to rev a little higher, and that's where they make their peak powers at a higher RPM. It would typically be, I don't know, 5 gram or just under that, 4.8, 4.4, somewhere in there. We're just going to go ahead and leave the 6.1s in this bike and go ahead and put the Variator back on there, and it's key to the spline shaft right there. Pop the starter bend X back in. Take the clutch assembly that we torqued in the previous step. You see the belt, it's got an arrow, points that direction. That's the direction the belt actually rides when it's operating. You pull this up and kind of twist it, get the belt in there, pop that on the shaft. See the belt's right about there.
Kind of deglazing the brake drum, getting that ready to go back on.
And you can set the fan kind of, and you can see there's 4 little key spots that line up. Again, with this replacement nut, you can put a small amount of blue Loctite. All the technicians here at Vespa Motorsport put some blue Loctite and torque it to the correct factory specification, and we never have a problem with any of these nuts ever coming loose. We have lots of bikes that people have been playing with themselves, but the nuts come loose, damage the crankshaft, damage the pulleys. Very critical that these get torqued, and definitely a good idea to replace that center nut.
You want a little Loctite, robot?
A little Loctite, that will put a dab on each shaft. Don't get out of control with it.
And what is that one? That's the Variator, right?
Yeah, it's a
14 foot-pounds and then an additional 90 degrees?
That's correct, yep. And the back pulley is?
Back pulley is the driven pulley. That one's 31 foot-pounds.
31 foot-pounds, 14 foot-pounds, and then an additional 90 degrees. So
both very, very critical torque settings, as Robot was saying.
And make sure that this is still keyed in there. You saw it kind of dropped out right there. And to get them started.
We're basically doing pre-torque with just the hand ratchet. Obviously you have to have a holder to check them correctly along with the torque wrench.
Torque the clutch, 31 foot-pounds, have the torque wrench set. And there we go. This front one. You carefully wedge number 3, number 4 screwdriver. You need to hold it quite a bit in place. Set this to 14 foot-pounds.
14, yeah.
So we have that 14 foot-pounds. Steve's going to pull that screwdriver in there. Going to make sure it keys with the.
See what's going on. Sorry.
Right about there. Hold it right there. There's 14, and we'll go ahead and do another 90. And you can visually do a 90, pretty much there, and 90 degrees. Or you got a torque wrench like this, you could actually set 90 on it. And we have that set to 90. Steve's gonna need to hold it extra tight. And this, okay. And that just indicated that we did 90 degrees, and the final torque was around 35.7 foot-pounds.
And again, we were using a nice, good quality number 3 Phillips. Just so happened to mesh with those teeth perfectly.
Yeah, number 3 or number 4 right here when you're taking out, and when you're tightening it right there. And very critical that you don't let it slip, or it's very strong right here, right where the bolts are. All right, belt cover's ready to go back on, and we're ready to pop the motor back in.
Upjet the carburetor. We've carefully taken off the float bowl. There's 3 perimeter screws. It's a Phillips. They're torqued on there very, very tightly. You don't want to strip those out. You got to, put a lot of downward pressure as you're actually cracking those fasteners loose. These bikes come with what is classified in the industry as the small round key-in jets. It's a 5mm, so it's basically 5mm of diameter of the head. There's a 5 and a 6mm that are common in Key-ins. This bike comes standard with the 75 main jet. We haven't really done too many of these kits, but from memory, we're going to go ahead and upgrade to an 80. And you know, when it comes to jet sizes, there's a tiny precision drilled hole that runs down the middle of it, and that basically determines the size of it. But the key thing dimensionally, these are the small round or the 5mm round Key-in jets. And again, the 5mm is the diameter of that head. Robot's got the carburetor off in the float bowl.
Yeah, main jet goes right there. The 4-valve engine, it's jetted differently. The carburetor is slightly different. They come with a 72 main jet, and typically the range of size for any of these carburetors would be 78 to 82, kind of just based on your elevation. Trial by air, if you really want to analyze it, you could check your plug, or you know, go get the thing dynoed, have a wideband O2 hooked up to it, and really get technical with it if you want.
So a small little flathead screwdriver to reinstall that. You notice the float bowl's got like a definitely reusable like molded O-ring. So there's not really a carb gasket set or anything each time you get into these things.
But pretty important that you rejet them with these kits. They tend to run a little on the lean side. Some of the other kits, like the 150 kit, we found you don't really need to rejet them, but these you do. Make sure the carburetor is perfectly clean. Make sure idle jet, you don't need to change out the idle jet. The stock one works fine. For the record, the idle jet is that other cylinder there, right, Robot? Yeah, and if it's severely clogged, we have replacement idle jets, 35. Make sure the accelerator pump works. Kind of push that little button. It kind of squirts a little bit of fuel out of there. Obviously, make sure it's clean inside the bottom of the bolt. Don't want to be really, you know, working on a carb that's dirty. It needs to be perfectly clean and running perfect before you put the cylinder kit on. Don't want to try to troubleshoot problems after you put the kit on if the scooter originally had problems. Go ahead and replace the 3 screws. And you can see I've left the whole carburetor in here. If you need to do a deep clean on the carburetor, it might be a good idea to remove it, but just for the main jet change without the engine here, pretty simple to do while it's still hooked up. Keep in mind, when you flip the carburetor over, it's going to dribble out some gas out of this overfill. It might drip some gas down in the air filter.
Perfectly natural.
Yeah, may want to take your air filter cover off. Check the sponge filter, clean if needed. Clean any excess blow-by oil or the gas out of it.
Oh man, the vaporless cigarette smells so good right now. Oh, a kiwi? Let's leave it. Keep it rolling. Oh man.
Okay. Back to this thing. The intake manifolds. Some have a gasket. This has got like an integral O-ring. Make sure it's in good shape. If it's pretty dried up and hard, you can put a real small amount of silicone on there, or if there's cracking on manifold, it'd be a good time to change out the whole entire manifold. Make sure this vacuum hose isn't cracked. Replace fuel line or vacuum hose as needed. We're going to go ahead and put the motor back in and hook all this back up.
A whole new world! You guys ever seen Little Mermaid? Remember that part? That's what this bike feels like now. It's a whole new world of performance for this fire-breathing LX50 that has now got basically an 80cc kit on it. Couldn't really do the video footage of us test riding out in front of the shop because there was a gang shooting out there, mean streets of San Diego. So we're on lockdown inside. We did a little test run before the hail of gunfire rained out. Robot verified that this thing got up to 55 indicated on the flats. Pretty huge increase considering before the Variator, before the cylinder kit, before the camshaft, it would maybe do what, like 40 or something indicated on flats. Where'd you go, Robot? All right. Robot is tuned out for the night officially. But other than the top speed increase, there's actually a huge increase in like torque. So up the hills is significantly better. If you ever do throw a passenger on it, you'll definitely be praising the improvements of the cylinder kit. Very common package of parts that we ship out at Scooter West. Again, we did the Malossi Variator kit, the Malossi camshaft for the 2-valve motor, and the Malossi cylinder kit.